welcome, Oleg, or should I rather say thanks for having me.
You're welcome.
We are in the factory right now, and we've previously been to R&D center. We've done a full tour. I was told by your co-founder, Alex, and yourself that the technology that you're using is not revolutionary, but the processes are.
Well, it's yes and no. The technology, the goal of the Kubi is to use widely used technology in construction, widely used materials, just not to have the constraints of the government, of the townships, and so on. But with the same construction technology, we change the process itself just to make it revolutionary.
Mm-hmm. Okay. So what is so revolutionary about the process, again, if you can
Well, one of the
elaborate.
main stuff, in one process, we put everything at the same time, like a turnkey solution. Mm-hmm. It's designing a logistic problem with materials, producing kit of parts, assembling on the construction side, plus maintenance building. This is a whole process that depend on each other. Mm-hmm. And when we design them, we design it at the same time, machines, kit of parts, and tools that help us to assemble.
Mm-hmm. Many people would say that construction is a supply chain problem, and once you can capture the supply chain, then the construction should nicely flow into a structured process. So what's your answer to that?
I 100% agree with that. Mm-hmm. The construction is everything related to logistics. And if you will solve the logistic problem, you will solve the construction problem. But one of the main problems is not easy just to solve the logistic problem, because we are speaking not only related the logistic of materials. This is the logistic of tools, this is the logistic of information, this is the logistic of assembling, and this is the logistic of parts, this is the logistic of subcontractors, and this is a logistic of the soil, a lot of types of logistics. Mm-hmm. And to solve them, you need to have the system that will try to use each aspect of each type of the logistics at the same time.
Mm-hmm. So maybe let me get you back to the origins. How did you get immersed into mobile microfactory subject?
Well, how we come up with this idea?
Yes.
We understand that when you build homes and when we begin to design the factory itself, we saw that we need to move a lot of tons of materials, because the factory consumes roughly 3 ship containers a day. Mm-hmm. And that's why we need to design it in some, that's why we understand that itself, the manufacturing of the houses, this is the big logistic material problem. Mm-hmm. And the obvious approach is, well, why not to have the manufacturing as close as possible to the construction site, mm-hmm. just to make it as short as possible, the distance to make it short as possible. Mm-hmm. It's obvious stuff.
How did you come up with it? Was it like a challenge that you came up like during some construction in the past?
Yeah, well, but our approach was a little bit different, mm-hmm. because in the beginning, when we tried to design Cuby, we begin to think what will be after 10 years. Mm-hmm. After that, we begin to understand how we solve this problem in 10 years. After that, we begin to design machines, and only after that, we begin to design, we solve the logistic problem. Mm-hmm. After that, in our mind, after that, we begin to design the machines, and after that, we begin to design a kit of parts. Mm-hmm. It's absolutely different approach that other startups is doing, because they come up something, mm-hmm. and after that they find a way how to solve it, they find a way how to embed it into the system, into the global operation, how to sell to the construction company, and so on. We did in an absolutely different way. First of all, we understand the problem, we understand how to solve them, mm-hmm. and only after that we design the system itself. Mm-hmm. And that's why the obvious solution is like that. We come up with a mobile microfactory that moves to the construction site, and mm-hmm. after that we begin to design the kit of parts and the technology itself.
Okay. So going broadly again, can you tell us what's the current state of offsite manufacturing?
Do you mean globally?
Globally, yes.
I think that right now it takes no more than 5% of the total volume of the construction in the world. I think that no more. Because offsite manufacturing is it's a manufacturing. To begin to use the manufacturing approach, not a lot of construction company, a lot of construction people understand the manufacturing philosophy, manufacturing approach, and so on.
What's the philosophy of manufacturing?
Of the manufacturing, I can explain you. In the construction, it's a project management system where there is a guy who control everybody, subcontractors, workers, and so on. He have a plan. And if something goes wrong in this plan, all the project is collapsing.
Yeah, everything goes to shit.
Yeah, it's a project management system.
Cool.
In manufacturing, it's a different approach. There is a conveyor belt, and in this conveyor belt, one process control another one in the line. And if something will happen, full line is stopped. That's why you shouldn't have somebody who control it, and you have this waterfall of tasks, and one depend on another. That's why to control this line, you need to control only one department in this line, not all of them at the same time. And based on that, this approach gives ability to control quality and to control speed. But for sure, there is some restriction because in the manufacturing, you have some restriction of the design. You can't create, for example, castles with the stones or something like that. But you can solve some problem regarding, for example, single family housing or something like that. This is called standardization. The same problem that Henry Ford had. Do you know that in the beginning of the last century, when Henry Ford began to come up with the conveyor and with the machines, and in the industry there were a lot of design bureaus, all of them produced different type of cars without any standardization, and the price of the cars was so high, and the quality was so low. The Henry Ford come up with the idea, well, let's produce one type of car.
For everyone.
For everyone, but only one type. And set up it in the conveyor. He shared all of this complicated process of designing and producing the cars into very simple operations and begin to produce it. The same situation we have right now in the construction. Because we want something extraordinary, not standardized. And for sure, we have high cost and low quality. This is a reasonable stuff.
So the way you picture it is there is a conveyor belt in a traditional construction, and there's someone managing this conveyor belt, and it's not doing its job properly, and then everything...
No, it means that in the construction, you have project management system, as we discussed with you. There is a lot of processes. One guy supply the windows, one guy is doing the plumbing, one guy is doing the electric, there is a labor who's doing the carpentry job and so on. And all of them depend on each other. If one guy fail, you will fail all the process regarding timeline. And that's why at the same time, you need to control everybody. In the conveyor, you need to control only one step.
Providing that the supply chain...
Exactly. Providing the supply chain, it doesn't matter.
Yeah.
It's the way, approach of how to operate the factory. You have a line, a conveyor belt, and in the conveyor belt, all the process is customized and depend on the previous one. And in this conveyor, you need to control only one, one level of that.
Does it not have...
And that's why you shouldn't have like a manager to do that.
Because I think that can work as long as the design is perfect, absolutely perfect. Because in traditional construction, there's various stages of design, and planning drawings, you don't use them for construction because you have to guess a lot of things. Based on what I've seen today in Cuby R&D Center, you have very, very detailed design of the homes, and all of the structural elements or even non-structural elements are perfectly put in the 3D, I think it was SolidWorks software. And do you think this is part of the reason why Cuby makes sense?
Yeah, 100%. It's more detailed, information. More detailed information you have, less mistake you will do. This is a reasonable global rule. And that's why in the construction, they have less information in the traditional construction. That's why they're making more mistakes. We have more information, more, system that have less, less mistake and so on. And in the construction, they also do less mistake.
So speaking of current offsite manufacturing state within construction, we have to mention a few previously large companies which failed. Some of them would be Catera, Viv, Mighty Buildings, Diamond Age. Have you got any learnings from those failures?
Well, based on our philosophy, if you do something that you're doing first in the world, you shouldn't look on your competitors. Because if you look on them, you will make the same mistake. For sure, you see what they're doing, you see their mistakes, and for sure, you need to understand what not to do. But it's not the rule if you have a success. My point of view is that a lot of companies in our industry who try to innovate it, to innovate in new technology and so on, they are only solving very narrow problem in the construction, doing frames, doing the walls. But in the Kubi, in the beginning, we understand that we need to do the full cycle, from the horizontal work to assembling to finishes, because we have absolutely different customers. That guy, to whom you explained them, maybe except on it was Catera also. Their customer was a big GC, and they provide to them the solution or technology that they need to embed in their ongoing work. In our case, our customer is the developer.
So you're providing the finished product.
Yeah, that's why, that's why for the factory consumes the raw material in the beginning and have final assembled building at the end. This is the full story of Cuby, because the goal is just to cut off everybody in this conveyor. As my goal and my goal in future, when we will have the ability to provide to the final customer building that he can build digitally in the internet, push the button, and after some months, maybe months or two, the building will be staying on that plot that they can have. This is the goal of that. I hope it will be like that.
So you've got quite extensive background in physics. I think you have PhD.
Yeah.
Yes.
I have PhD in economy.
Okay, and so you've been successful in building and scaling deep tech companies. Can you tell us a little bit about your background and why you are the right person for the role of?
It's difficult to say that I'm the right person, but I will explain you my background.
You have to believe that.
Okay. Well, I have physicist background. I'm an engineer. I set up a bunch of manufacturing companies myself, and I own them now. One of the biggest of them, it's called Incata. It's 200 plus employees, hardware outsourcing company who help deep tech startups to go from idea to mass production. And I have PhD in economy. I wrote a book, how to create the engineering team and how to operate them. And in Incata, last 10 years, what I did, we took the scientist, as I told you, who almost finished his development, and with my engineers, we'll help them to go from ideas to mass production. That's why I start manufacturing a lot of time, and I know a lot of mistakes in the deep tech. Well, one of the main mistakes in the deep tech is that the deep tech startups don't understand the market.
Why?
They don't understand the size of the market.
Okay.
Because they come up
are
something,
overestimating it or underestimating?
It's overestimating. And last time when we make a decision what we will do next, we will choose that area where the market is the biggest in the world. The construction is that market where the biggest in the world, but at the same time, this market should have less innovation as possible.
It should have at least innovation as possible.
Yeah.
Why is that?
And do you know that there is a joke that if Jesus will come back on our earth, only one profession that he can recognize, it will be the construction worker. Because do you know he was a carpenter? Nothing changed 2,000 years. I think that right now we will find the job for the GCC. Well, and that's why this industry is very big. It is less innovative in comparison with manufacturing and other industry. And that's why we think that we can do something here with our expertise.
Can you share with us some specific examples how you leveraged your experience in growing and scaling these deep tech companies?
Well,
And how does it render onto the Cuby?
you know that we embedded here in Cuby all our experience that we had on my previous companies. It's a software how to operate in manufacturing. It's a software how to control the designers and how to do this scale of development work. And well, that's why all the experience how to develop the deep tech process itself, because it's also very complicated. Do you know that development, you mean that project development, it's look like a construction. It's also not controlled. Because the same team in the development process can do the same projects, and the result also can be different, like in the standard construction approach.
Well, because everything is dependent on people and their behavior, which are
Exactly.
not systemized and processed.
Plus is, you know, depend of the group of the people and connections between them. And we have the exact software, processes, standards, and everything that we have just to help us to control this a lot of people that we have now. We have roughly 200 employees, roughly. Most of them it's engineers, software, hardware. And just to control this big amount of people, it's you need to have a system.
So, sorry.
Go ahead.
So there's quite a few startups who are trying to put more manufacturing soul into the construction. Why you think you are ahead? You mentioned a little bit about your vast experience and vast number of engineers that you've got working. But maybe you can mention some capital constraints that startups in the Western world have when trying to replicate the success of what you've already achieved.
Well, do you know that in the construction era, the startup that start doing its startup, they don't understand in manufacturing, not a lot. And they even can't estimate how much time and engineering hours they need just to be at the finish line. Because everything in construction is obvious. It's a beam, it's a column, it's a roof. But to do all of these nuances, just to fit them well, just to do the click system.
At this granular level.
Exactly. You need to spend a lot of time, a lot of money.
How does the current mobile microfactory differ from what was initially at your ideation stage? How has it evolved? Is it a completed project or completed product? Or has it changed a lot from initial blueprints and sketches?
Well, do you know that the mobile microfactory, we have when we set it up, we have adoption period and adoption during the process. And based on the adoption process, we do the research, run the codes and what the customer needs. And based on that, for sure, we change it a little bit. Just it should fit to the technology. It should fit to the region needs and the code. That's why do you know that itself the Kubi MMF, it's a product, but it should be adapted by not the blueprint. It should be adapted by the region. But itself, the size of the building, the plans of the building, and so on, it's the same. It's like a copy-paste factory.
Okay, great. As we were talking last night during dinner, you mentioned analogy to Starbucks and IKEA.
Yeah, there's something middle between that.
Can you explain?
Yeah, well, the Starbucks, it's a process. Because a lot of company can sell the coffee. But they're doing is with a replicable approach, that they can replicate this business everywhere. And when you come to the Starbucks everywhere, you will have the same quality of the coffee everywhere. It's good or bad, it doesn't matter. But the same quality and the same stuff because the process is the same. Our approach is the same, that we want to have that each factory, Kubi Factory, will have the same quality of the buildings everywhere when it's built. This is Starbucks.
IKEA.
The IKEA, when we produce parts and deliver it on the construction site, it's assembled with unskilled labor with the same approach that IKEA is assembled when you buy, for example, something from the IKEA market and you assemble it yourself. It's designed very precise and designed in somehow that unskilled customer can assemble it himself.
Also, supply chain is the analogies from both IKEA and Starbucks, I guess, right?
The supply chain?
Yeah.
Well, I don't know how the supply chain in IKEA is working in Starbucks, but I think that in Starbucks it's working much better than in IKEA.
It has to, because it's live delivery of products.
Exactly.
And on a daily basis.
100%.
You can't store it that long. Okay, so you've invested over 400,000 engineering hours into where you are at right now. What are the key technical challenges when designing Kubi?
Well, do you know everything, when you look on the technology, everything is simple and obvious. But we have so a lot of stuff that we need to solve, so a lot of silly problems that we need to solve at the same time. And the problem here is that you have so complicated numbers of the silly problems at the same time.
So you need to take it one by one, or you having so many engineers?
No, you need to solve them at the same time, because if you solve one, you will take one solution, it will affect somehow on another one. That's why you need to solve it at the same time.
Can you give an example maybe of a problem that you recently come across and solved it?
Well, okay.
On a daily basis.
Okay, let's say, for example, we had a lot of problems for sure, and this is our goal. This is our job, is to solve them. For example, when we begin to use the sandwich panel, we have not very good isolation between the seams, and that's why we
need the seam?
Yeah, the connections between two panels, and that's why we need to find the exact appropriate glue that will work there. When we build the first building, we take one type of the glue, and typically it looks good. But after half a year of using the house, we see that we have very thin layer of the leaks there, and that's why we need to find another glue of that. And that's why, but only this approach we can begin to do.
Okay, Oleg, maybe we can talk a little bit about what does the process of installation of the home looks like? Yeah.
Well, it's a typical assembling, like you assemble the car or assembling some machine or something like that. That's why there is a stages.
So can we talk about maybe first stage will be foundations, I guess, right?
Okay.
Yeah. So maybe let's elaborate a little bit on each of the stages.
Well, regarding the foundation stage, we have two types of foundation. It's helical piers and it's concrete slab.
Yeah.
And based on that, we just deliver the packs with the helical piers and with all materials that it's need. And on the construction side, we have an electric tractor with a hydraulic system. We screw it there, one by one, by the instructions that the construction workers have. The next stage is we need to put the steel frame on the helical piers, and we have adjusted bolts just to make the level. Yeah, just to make the level of the frame right. And the assembling is doing without any weldings. We have a special patent locks. We use the rivets in that, and that's why you can't make a mistake, because you just put it in, put the rivets, and shoot it. That's it.
And so that is a piling system, that is a slab which sits on the piling system, or a steel structure and the slab on top of it?
Yeah, well, if we will take the screw pile foundation, in the screw pile foundation, we put on the frame, we put the sandwich panel as a floor isolation, plus we pour the concrete on it. And we did that for just to do additional sound protection and sound insulation. Because if your floor is not heavy and is not solid, when you just work or run, so the people in another room can feel it. And this is a typical problem in stick-built homes. In our case, we're doing the concrete slab on that, and we just solved this problem.
Okay. And what are other stages after you have this concrete slab and you install in the UK we call it superstructure, so steel or?
Yeah. Well, we have roughly 45, but in general it's 37 stages. And each of them is fed to the inspection process. For example, we have a stage for internal walls. We have a stage for electric when we put the wires. We have a stage like a pumping, plumbing, when we put all the pipes inside there. We have a stage with the finishes. We have stages with the ceiling panels. We have stages like terraces, a garage, fence, and everything just step by step. We just assemble the building.
One of the things is a key component here is the design. When you receive an architectural design, how does this get transferred into SolidWorks model of the structure or of the fully?
Yeah, the SolidWorks, we're not using SolidWorks when we design the house, because in the SolidWorks, we do the initial designing of the kit of parts plus machines. But when we begin to design the house itself, our software is taking from the SolidWorks already prepared 3D models with all information and put it into that coordinates that it should be. And it generates the house and the kit of parts itself and generated the stages. Initially, the construction process in the Kubi, we have a grid. It means that 10 feet on 20 feet. And based on this grid, we can design different sizes of the houses. But internal plans also can be flexible. We have a grid of internal walls. It's roughly 600 millimeters on 600 millimeters. That's why you can create different type of design inside that, not depend on the walls, on external walls. But we have a column with a grid 3 meter on 6 meter or 10 feet on 20 feet.
Okay, so you can shape the layouts within the 6 meter by 3 meter grid, really, yes? Structural.
It's structural stuff. Yeah.
Structural stuff, yes. And what I really liked when we looked at some of the SolidWorks visualizations or models is that you can very easily understand what was built in on site. Maybe tell us about some processes of how the design is being put into the practice, because lots of construction sites, they don't have enough details in design, which then generates problems or inaccuracies during the construction itself.
Well, as I told you that when we design the house, we automatically know where each part from the kit of parts should be installed. We know the exact coordinates. And we right now use additional reality system that point out to the construction worker with the phone where it should be installed, this or that part, with the accuracy roughly in 1 centimeter. And it shows step by step what he needs to do. In this software, he can look the video how to do that. He can see what the tools he can use and so on.
What if he's sleepy and he forgets to do something?
Yeah, but as it is a click system, based on that, he will not install it.
Okay.
Or, for example, he can do the next step of that if you didn't do the previous one. Plus, every 2 hours, the master is checking, all the process that is going there. And we have our internal inspector who check each stage when the team is ready with that.
So in your R&D center, I've noticed there's like a 3-stage process. There is R&D, then there's the middle, remind me?
Yeah, technological guys.
And then there's the factory. Trial factory, right? So engineering, which is the R&D center, is very close to the manufacturing, which is the 3rd stage. Yeah. So tell us how do they collaborate and why is it created in a way that it's only a glass wall which divides the R&D, then the technological guys, and then the factory?
Well, before the mechanical engineering begin to design something, they're working roughly 2 or 3 months as the workers in our manufacturing, because you need to understand all the machines and processes and not to create air castles when they begin to be the designers. Because in the construction, it's one of the big problems when there is architectural or engineering. They have never been in the construction themselves, and they try to design.
They can only do the lines.
Yeah, they can do that, and they try to create something that they didn't understand what to do and how to do that. And we, just to solve this problem, we have this solution. Plus, we have a manufacturing as close as possible to the designers, and these guys is assembling everything that they design by themselves, and they help the workers to understand what they mean under the drawings or 3D models. That's why we have them as close as possible.
And also, I guess this iteration process is very short.
The iteration is shorter, 100%, because do you know, you need to make as much mistake as possible and as fast as possible.
Solve them as fast as possible.
Yeah.
Move fast and break things.
Yeah.
So tell us how your core engineering team in the R&D center is structured.
Do you mean this is structure of development?
Yes. How are they working together? Is everyone working on the same problem, or they have different problems? Some people are looking at the foundations. The rest of them are looking at.
Yeah, for sure. We have some teams that have their own, main tasks. Some of them is working with the foundation of kit of parts. Some of them is working especially with the window manufacturing. Some of them with welding, and there is a leader of each, branch. And each of them have, the engineers that work with them. But if in one branch we have less job, we can remove this engineer from one branch to another. So this is how it's
common sense.
Yeah. Common sense.
Great. Tell us a little bit about cost of R&D and why other companies/startups will struggle to get to the point where you are.
Well, as I told you that in the construction, the people even can estimate how much time and engineering they need to spend just to do this simple stuff that they think in the beginning. And
what are the numbers, you think?
Do you mean that?
The numbers.
Do you know numbers of mistake?
The dollars numbers.
How much it costs what?
How much it costs to get to a stage that you can have a system that is figured out.
Now?
Yeah.
I think that it's more than $100 billion still more. If we'll calculate, okay, let's say, we've discussed with you that we spend 400,000 man hours where we are. You can multiply it on the salary in the United States, and you will have just
enormous, gigantic numbers.
Yeah. Because this is, this is one of the main mistakes, as I told you, that people can't estimate it because they see it's a silly problem. We can solve it tomorrow, not the day after tomorrow.
Great. So I wanted to touch on the constraints and limitations, if there are any, of the sizes of these homes, and what is the target audience of the produced product, such as home?
Typically, that technology that it could be V1.2 that we're doing now, it's our flagman technology. Our target is the single-family houses, or maybe four.
What's the square footage?
Well, the normal size is starting from, I think that 600 until 5,000, something like that. This is just roughly range that it's reasonable to produce with a Cuby, with this type of the technology.
And one factory would be able to produce how many a day or a month?
Our typical house, it's 2,000 square feet.
2,000 square feet house?
Yeah, and the production capacity of the factories that we calculate all the machines and so on, it's a house per day.
House per day, 2,000
square feet per day.
Per day, which means we're talking how many? 20 a month then, right?
20 a month. Yeah, well, it depends how many shifts they have and will you work on the day offs or not.
And that is this 30,000 square feet facility. And how many employees would work on this?
Yeah, it's 40 employees, 35, 40 employees in 2 shifts in each of them. Plus, it's 160 person on 20 construction sites at the same time, because all our process is designed by the 4-guy team.
4-guy team?
Yeah, just for the team of 4 guys.
Okay. So on one house, there's only 4 people working on it?
Yeah.
On site?
On site, and they're doing everything, all the stages. Plumbing, electric, shelving, that, like framing and so on. They do only one team.
That's impressive.
Thank you for that.
Okay, let's move on to what are critical integrated systems, if any. Talk software and hardware that enable efficient manufacturing of homes.
Can you explain it a little bit?
Yeah, so if there are any integrated systems, like, robotics, AI, that are helping to manufacture these kits of parts.
Yeah, for sure, for sure. To know that all the parts is predetermined. And if it's predetermined, to each of them in the software, we can put the exact instruction what to do. Plus, we have a management system. When we put into the conveyor numbers of houses, the system automatically share it to the stages and to the parts that they need to produce, and put all of them into the chain of production. And that's why on the construction site and on the factory, the worker on the phone have the task, what he need to do right now. You need to go to the window department, and you need to do this, and that. Finish. See the instruction if you need. After that, the next task come to them. And that's why the main idea of that is just everybody need to work to all departments, all machines after some time, and we have a special learning system, and the system will not allow you to work on the machines if you will not pass through the tests, and the system know, do you have some skills on this machine or not, and he will give you the task if you have. That's why this is operational system that remove the workers inside the factory from one machine to another where we need the demand. Because do you know that one of the main problems in the factories is that when you have machine and you have a labor, and the guy, you teach somebody to work on this exact CNC machine, and you have no job now, the worker is sitting there and waiting, and you pay him the salary.
Yes.
In lean manufacturing approach, it's a different approach. The machine can wait, but all the people should work nonstop. That's why you can remove the people from one stage to another, and so on.
So we've been through the factory, through R&D center, and on every station there is one word with a card which says Kanban.
Yeah.
What is Kanban?
Well, in translation from the Japanese language, the Kanban, it's called signal. This is a signal to buy, to supply, or to do. The card, at the same time, is an information how much materials you need to bring there and when you need to do that. Plus, we have a manufacturing Kanban cards, we call it steel cards. In the steel cards, this is a task that you need to produce necessary amount of parts right now. And with these Kanban cards, we control all manufacturing. We have thousands of them. And these cards help us to produce standard parts. But at the same time, we call it static parts. But at the same time, we have dynamic parts. Dynamic parts is depend of the layout of the building. Because, for example, you can produce it before. You don't know the plan of the building, and the software have 80% of the standard parts static and 20% of dynamic. It's generate the task for the CNC machine online when we give the task to the factory to produce this house, and the CNC machine produce based on exact address and exact project, exact parts with exact sizes.
And for the record, in the toilet, above the last toilet paper roll, there was also a Kanban card.
Yeah, for sure. Because do you know, one of the main principles in the Kubi is to teach people, and we need to use it everywhere. It's not make sense just to use it, for example, in the factory initially, but not to use it in the toilet.
Do you use it on your wife and kids at home?
Yeah, for sure. But no. Well, it's not make sense for sure to use it at home, but it's possible. For example, for me personally, in my materials that I use at home, when my construction materials and tools, I use all that tools that an instrument that we use here. It's a Kanban, a 5S, and so on, for sure.
Through our conversations today and yesterday, actually, you mentioned some patents. Maybe without getting into details, but why patents? Why is it relevant for you to hold some patents?
Well, do you know that we saw a lot of engineering at the same time, that we need to be careful what to patent, what to not. Because you know, if we will patent everything that we invent every day, we will spend all our money just for the patenting. Yeah. That's why we have a lot of them. We have more than 20 patent solutions right now that protect the technology itself, the machines and the process and so on, for sure, but we are not doing it for a day. We are not spend so a lot of energy in that, because we are, our philosophy is like, you need to be faster than other. If you will be faster, you will be the winner. It means that you will be ahead of everybody. And if you will just spend a lot of energy just to protect what you did, for example, a year ago, well, the world right now is changing very fast.
Yes.
And that's why, this is not a good philosophy to win.
Fast and accurate.
Yeah.
Cool. But accurate is, I guess, in your case, it's a default setting. It is something that has to be.
Sure.
Yeah. Okay. Can you explain the concept of a kit of parts?
Well, yeah, for sure. As we discussed with you, that the construction process consists of stages, and the factory produces parts to each stages. And that's why numbers of all these kit of parts to each stages, this is a kit of parts for all houses.
So how many kits of parts is in, I don't know, one house?
Yeah, well, it's roughly 300, 400, something like that. It's in total that the factory can produce.
And these kits of parts are being supplied from the factory, onto the construction site.
Yeah. And the factory consumes raw material and produces parts and deliver it to the construction site.
And the construction site, does it need to be prepared in a special way, or how do these kits of parts arrive in the same day, or?
Yeah, well, we have near the construction site, we have 2 places on the ground where we need to put the parts to stage number 1 and number 2, let's say. On the factory side, we have parts for the stage number 3 and 4. When the construction guys finish the parts number 1, all the parts for the stage number 1, the system gives the task to the transport system to deliver the parts for the stage number 3, and gives the task to the factory to produce parts for the stage number 5. That's why this is pooling. So
it's all automated?
Yeah, it's automated. It's a pooling system. It's a pooling system when you pull. Well, one of the lean manufacturing principles, you need to use pull system instead of push system.
What is push system?
Push system in the construction, when somebody come and tell you, you need to do it right now. But the pull system is like that. This is a job for you. When you will be ready, you can pull it and continue doing that.
Smart.
Yeah, this is a pull system, and the pull system can give us the ability to control the process. Because if you use the push system, you have a traffic problem.
Yeah, this person might be doing something different, or this company might be doing something different, and they might have some delay. So the concept of mobile factories, can you say a little bit about the size of it, and how much time does it take to to install it, to have
Well,
it fully assembled?
the installation period, it's roughly 1-2 months. It depends on the skills of the workers there. For sure, for the first one, it will take 2 or 3 months. But after that, when we'll move the factory from one place to another, it will take roughly months or months and a half, something like that. The size of it, it's 30,000 square feet, not including the warehouses on the sites of the factory, because we have additional warehouses on both sides of the factory just to store the material for 2 months. And it's additionally maybe, I don't know, it's 20,000 square feet, something like that.
And how much time does it take to produce one of the factories?
Well, we have a lead time right now a year.
A year.
Yeah, because we need to produce all of the machines, containers, put them into the containers, customize, so on. Because we produce right now more than, I think that 50-60% of the machine inside the factory, it's not exist in the market. We design them from the scratch and we produce them ourselves.
That's very impressive. Like, why did you decide to do that? Could you not use like typical tools or typical?
Yeah, because the typical tools not help us to solve the logistic problem, because the typical tools is only feed to the mass production. I will explain you the reason. Let's say, for example, I will buy the manufacturer to produce windows.
Which we can see.
Something like
Just
that.
over there.
But a lot of them is designed from the scratch, from ourselves. And to earn money, if you are window manufacturer, you need to produce a lot of different type of windows, and you need to produce a lot of windows at the same time. Your production capacity should be thousands of them. And you earn small money to each for each window, and in this case, you
build up your revenue.
you'll have a business. In our case, we need to have 10 windows a day. But the size should be as small as possible just to fit into the containers and into the line. And such a kind of solution does not exist. Because by the business approach,
it's not viable.
It's not viable just to maybe it's viable for some reason and so on. But in our case, it's not reasonable for us to buy the big machines, to spend a lot of money to do that, and to have this very high production capacity. We need to have good quality, same price, but low, small production capacity. But we need to have at one factory everything produced in-house. That's why Kubi Factory, it's under one roof, a lot of factories. A lot of factories under one roof that produce all kit of parts for all stages.
So speaking of the inside of the factory, there are roughly 40 stations and 300 machines and tools.
Something like that.
How is this managed as the stations? And you explained it a little bit earlier, but if you can elaborate a bit more, how?
Sure.
And also, I've noticed, I don't think we've got one next to us, but the tool boxes. Also, if you can elaborate on those.
Well, how we control the factory. We have a Kubi Factory software. It's called Kubi Factory. It gives tasks to the labor, plus it gives tasks to the CNC machines when we have buildings that we need to build. That's why on each department they have a separate server, and this server is communicate with the central factory server, and this system is give the task to the CNC machines what to produce. Regarding toolboxes, we thought how we can bring all the manufacturing philosophy to the construction site, because you have no space, you have nothing, you just have just the soil and that's it. But you need to bring all of this process there. And in this case, we need to begin to produce toolboxes, containers with everything inside there and so on, and try to have the same approach, but in the construction side. And the toolboxes, the task is like that. For the construction worker, the task is looking like you need to take from the toolbox number 1, you need to take the drill number 2, and you need to do this hole by the instruction number 1. That's why it's fully operated and step-by-step instruction what to do with exact coordinates where you need to take it.
What in case if someone does something wrong then?
Do you mean that when he assembles?
When he is like, actually, yeah, because it cannot be done wrong, right?
Yeah, because when you
It will
assemble
not
the
fit.
Lego, you
It
do
will
know
not
that
fit.
there is only
Yeah.
the exact position where you can install it.
It will not fit, yeah?
Yeah.
So there's 40 stations and they perform different manufacturing tasks, yeah?
Yeah, based on the stages.
Based on the stages. And how much technical ability someone needs to have to operate these?
Well, we have a learning system. We call it Kubi learning software. And we use it on the construction side for the tools, for the materials, and for the machines. Before, the system will give you the task that you need to do something on this or that tool or this or that machine. The system sends to you the task. You need to write the instruction, you need to see the video, and after that, the AI system generates to you the questions just to understand, do you understand what's going there or not? The next step, the system gives you the task to go and to work with somebody who know what to do and who passed through all of this process. And after that, only after that, the system begins to give the exact task to you personally. To each machine, it will take roughly 2-3 days.
To learn.
Yeah, to begin working.
And you said-
But everything is very obvious and not complicated. Your task is just, you need to take this material, put it here, and in the controller, you need to push the button. That's it.
And the whole of this, concept of Cuby is to make these homes of a good quality and cheaper.
Yeah,
Yeah, and faster, perhaps, right?
perhaps.
Yeah. Okay.
Yeah, for sure.
How cheaper? How faster? And yeah.
Well, right now in the US, we have a self-cost of the factory, it's $100 a foot. But this is self-cost. This is without profit of the factory. The speed, the factory produces a house per day, 2,000 square feet. And the assembling period is 35 shifts.
35 shifts.
35 shifts, yeah. It's
2 months.
It's 2 months in one shift, but typically 2 shifts can assemble the house. That's why it will be less than a month.
How much do they cost to build?
This $100 per square foot, this is the total cost of manufacturing plus assembling.
Okay, of the factory.
Yeah.
Okay. And the number of homes, I think you mentioned that 200 homes in a
A year.
year.
Yeah, and it's roughly a house per day. That's why it depends how many working days do you have in the month.
Yes, yes. And 200 homes a day of, let's say, for one client, which are the same homes, or maybe
No, it's
20 different variations?
it doesn't matter because the factory produces parts. It's delivery parts on the construction side, but the same type of parts, but different numbers of them. And it's delivered to the construction site where you assemble it.
Got it.
And when you assemble it, you have different house.
So how do you solve the logistic problems again, maybe? So how do you make sure that supply chains are satisfactorily delivering the parts and the materials onto the construction site?
How we solve that?
The supply chain problem of the parts and materials being delivered to the site.
Yeah, we are doing it, as I told you, with a pull system. When we have the parts already ready to install on the construction site for 2 stages, and for 2 stages, we have also ready parts that is in the factory.
And that includes also finishing,
Everything.
like layers, like, I don't know, paints as...
Yeah, for sure. You know,
Okay.
it's one of the stages finishes. In the
Okay.
packs, you will see the paint, you will see all the tools that you need to paint, you will see, for example, like gloves, and even tea and the sugar for the guys.
for the workers.
Yeah, for sure.
Okay. What about integration of robotics? We saw...
We have a lot of robots. We
Yeah.
have a lot of welding robots. We have a lot of installation robots and so on. But our goal is in future just to use humanoids.
Humanoids.
Yeah, because we have the exact task to each worker with exact coordinate.
Mm-hmm.
And humanoid in future, this is the best solution, how to embed them as fast as possible. Because we have the central server who give task right now to the CNC machines, to the robots, and to the labor, to the workers. Let's say, for example, instead of workers, we will have humanoids who will understand what to do because we have the exact coordinates, they have exact what to do, they have instruction, and so on. And they can do it, I hope.
So knowing you for a day and a half now and getting to know your inventiveness, I guess you will be working on humanoids yourself because you've got lots of very bespoke machines and tools that you have created just to fit within the factory. Yeah? Are you thinking about production of humanoids at some point to facilitate the production?
I did a lot of robots in NCAD in the previous company. I did a lot of machines. Well, right now, a lot of companies try to solve this problem, but you know that nobody tried to do it in construction. I don't think that right now we will just be first in the world who will do the humanoids. We 100% can do that because we have engineering power to do that. But right now we're tackling the construction market. And that's why we need to finish it to the finish line when the factory begin to produce one by one. We need to begin to conquer the market. And only after that, maybe we will think about it.
Okay. What about, there's a very common word in construction and outside as well, artificial intelligence. How do you embrace artificial intelligence, if at all?
Well, we have in the learning system, we use AI just to control the quality and control the knowledge of the labor. Plus, we begin to use AI system with our cameras just to control the quality and to check is the job done or not. Yeah, but because you know that we have the exact coordinates of each part, and the AI system is easy to determine is it installed or not, even without the inspector. For sure, in our process right now, we are not using it now, but we teach them. We teach AI system just to use it in future and just to do all the check, all the control processes. We'll 100% buy the AI.
Are there any critical KPIs that you use to monitor performance within mobile micro factories?
We have it for sure. Each part that we install and each part that we produce, we have the exact time and materials that the workers need to spend.
Do they have, so this time spent for the activity?
We know exactly how much time they need to spend and we check it and we put it there.
Do they get like a daily or weekly report about?
No. The system is doing automatically when they give you a task for you.
Okay. So does it say to you, you have 3 minutes or something?
Something like that. It sent you the task and that you need to do these 10 parts. Each of them is 3 minutes. That's why roughly you have 30 minutes to do that. But it doesn't matter because we pay for each part. And if you will do it faster, you will earn more.
So it's also intensive since the built-in.
If you will do it slower, you will have less money. That's why it's your motivation to do it faster.
Yeah.
But we check it many times in different operations, in different departments. And that's why we exactly know what to do.
Do you have any areas of process improvement? And how do you approach improvement of the process? Is it complete process right now?
Our philosophy is that you need to develop the process nonstop. And I think that we will improving the process with each house, with each factory that can be built.
A few times when you spoke with Alex and you as well, there was a concept of Papa Factory. What is Papa Factory?
We have a factory in China where our goal is to produce where we're producing machines and to supply it, because they have a big demand right now, how much factories we need to supply. And to produce and to supply the factory, it's a challenge. So that's why we need to have the factory, we have it, that begin to produce machines and the containers in mass production approach. And the goal of this type of factory for the next year is just to start to do 8 factories a year.
8 factory?
8 factories a year.
Okay.
And I think that in 2 or 3 years, our goal is just to increase the production capacity to 20 factories a year.
And I think the master plan is 750, or no, 225?
200.
200.
200 only in the US.
200 in the US in the next 10 years. Okay. Okay. Few times we mentioned Kanban now. I guess that's also taken from Toyota production approach. There are, I think, 14 components of the
14 principles. Yeah.
14 principles. Share a few, which you use like.
You use all of them.
You use all of them.
Yeah, well, it's very easy to use this kind of principles. I will explain you why. There is 2 types of problems. One of them, when you have a standards in the process and you need what to do. And another problem, when you have no process, what you need to do.
You don't know what to do.
You don't know what to do. And in this case, you begin to use the philosophy of manufacturing. And one of the main rules, if you don't know what to do, you need to follow these 14 principles. This approach helps to solve the problem which is not written in the standard or instructions. Let's say this principles it's a philosophy that help to do that. The principles very easy. You need to visualize all the process around you. We have no walls. We have no, for example, like boxes where we can store something and so on. Everything should be visible. If you see that, for you, it will help you just to solve the problem. Or, for example, like the problem, one of the principles is called Genti Genbutsu.
Genti?
Genti Genbutsu.
Okay.
It's called that, it's mean that you need to see everything yourself to make the solution, to make a decision. Each level
So don't rely on someone else.
in our company, they should make a decision only if they will see the problem by themselves. Not about it. For sure, they need to listen to somebody and so on, but you shouldn't make a decision when you will see everything yourself. And such kind of very simple, 14 principles help us just to operate the company.
Is it maybe 1 or 2 of these lean manufacturing principles that are the most important, relevant?
All of them.
All of them.
Because, for example, one of the main idea in lean manufacturing is called Kaizen. Kaizen, it's a process of non-stop development. It means that when you develop yourself, develop your company, and you do every day small steps in improving everything that you have, but in the long term, you will have very high jump and you have very high progress based on that.
Small improvements,
Small improvements every day, but in long term, you will have very high.
That's how compounded interest works.
Something like that.
Okay, waste. And how do you optimize for waste? Construction sites are known from wasting lots of materials. And
yeah, for sure.
How do you
there are several levels of efficiency in the waste. First of all, we have as we are producing the standard parts, we have the exact cutting maps. In the cutting maps, we know how much waste we have.
Because it's designed. The waste is designed.
Exactly. Yeah. We design the waste by producing the good cutting maps. And let's say, for example, we know that the size of the glass that we supply from the factory is, let's say, 10 feet on 10 feet. And we design mass-produced windows that is fit to the size of the material that we supply. And size of our panels at the same time. And that's why we know how much glass we will waste when we will cut that glass that we need. This is number one. Layer number one, that the waste is controlled, and we exactly know how we create it. The second one is from each department, we can split the waste. And that's why we can put the glass in one container, steel in another container, and we can even sell it. We can sell it after that. Plus, when we supply to the construction site all parts already prefabricated, on the construction site, they have 1% waste because everything is ready for them just to install.
Yeah, there's pretty much no waste.
Yeah, it's pretty much no waste. Maybe we have something, but we have back transport that transport everything that we will not install there back to the factory, and we know what to do with that, and we put it in this or that container. Do you know that the size of the business or the field is determined how much time and money you need to conquer it?
You need to conquer it.
Yeah. It's why if the market is big, you need to spend same percent, maybe 1% to 2% or something like that, but 10% of the market. But if the market is big, you need to spend more time and money related to the market with some industry where the market is small.
But also the fact that the construction of a home is a very complex activity, right?
But this is number two, because it's a lot of very simple operation that you need to do at the same time. Yeah, for sure. And that's why, not a lot of startups, as I told you, don't understand how much time they need just to spend to solve some problem in the construction area.
So you're saying that there will be more and more failures of a very well and heavily founded
because,
startup.
for example, in that area where the people don't understand, they don't understand how much time it will take. Let's say, for example, in EI industry, not a lot of people understand how much time it will take to design new EI. And that's why it will be not a lot of competitors. And that's why the strategy that they have is not based on the target and numbers. They're doing research. But
there's no outcome that they
because they don't know.
create.
It's research.
Yeah.
But in the construction, you see the result. You know how to do that. And you think that it's easy. You begin to do that. And during the process, you understand that you're far from your goal. And you need to spend 10 times more times that what you expected before.
Speaking of misunderstanding, of lack of understanding, maybe you must have spoken with plenty of potential investors in the past. What are the common misconceptions that investors in construction tech, or maybe general investors, don't understand about construction space?
Well, right now the situation begins to be a little bit better than, for example, 3 or 4 years ago. Because a lot of
3 years ago, there was no Bricks Bytes podcast, so people couldn't have knowledge, of course.
Yeah, but do you know that 3 or 4 years ago, a lot of VCs, they just tried to look on the construction startups with the same approach as with the software. And that's why in the deep tech also. In the software, you need to have for the first MVP, 8, 9 months. After that, you need to have some first monetization on that and so on. In this area, you need to have the first MVP in 3 or 4 years.
And that costs a lot tangible
materials. Yeah, and for them, the mathematics is not working. And that's why they're not, for them, it's much better to invest in the software. They can have that cash back, for example, faster, and they can understand how to help with this business and so on. But in deep tech and construction, no. They don't know. The timing is very long. The price is very high. And that's why it's very narrow funnel of the VCs that understand the deep tech and construction especially.
Let me ask you this. Where you can go wrong with Cuby? Where Cuby can go wrong?
Can.
Can.
Yeah, it's very complicated, question. Maybe we can be wrong regarding the design of the houses. Maybe some region will still think that this type of design of the house that we're doing, for sure we have a variety of plans and so on. And we think that it will be easy to sell it here, but maybe in this region the people will not like it.
But if you have common grid, like 6 by 3 meters, you can adjust, yeah?
Yeah, we have for sure, but maybe in some regions the people like only the concrete building. And in this region, for them, will be challenged to buy that.
We saw cladding, which is magnetic cladding, which looks like concrete.
It looks like, but right now we have, some customer who strongly want the concrete building. And there is some regions where the people just ready only to buy and to pay for the concrete buildings. That's why we can be wrong, maybe, that we think that the Kubi can fit to any markets in the world. But really, maybe it's not. In this area, we will come up a new type of Kubi, 100% with the same approach.
Kubi concrete.
It will be Kubi different. V1, right now we have, maybe we'll have V5 or V6 technology that will exactly fit for this or that area.
I should have asked you this earlier, but who is the customer of Kubi actually?
It's a developer.
It is a developer.
It's a big developer, yes.
How big developer?
Yeah, it doesn't matter how big. But I think that typically it's a small size and middle size developer who build 30, 50 houses a year. And for them, we are the exact right solution. Because we can provide to them the turnkey solution from the soil to turn exterior finishes, and they have no headache. We can sign the straight contract based on the exact price of square feet because we can manage and control it. And that's why for them it's good stuff, just even to have loans from the banks and so on.
Okay. Oleg, I think we are at the end. Thank you very much.
Thank you.